アンディ・メンデルソンよりプレゼンテーションさせていただきます。
Good afternoon, everybody. I'm really excited to be here. This is my first Japan Oracle User Group presentation, I think, that I've done. I'm glad to see you guys finally have a user group in Japan that's doing really well. So I'm here to give you an update on what we're doing with database. And let's get going. Just one point on this slide. You know, Oracle's database software has been around for over 30 years now. And the reason we are still around and relevant is that we are continuously improving the product and making sure customers know that Oracle has the best database technology as we go from one generation, like client server, to the next, the internet, and now to the cloud. We are continuing to invest really strongly in making sure we have the best database. And if you look at most of these enhancements we've done to the database, almost all of them preserve your investment in all these applications you've written over the years against the Oracle database. They're all transparent to those applications. You know, in 12c, we added things like Exadata, multi-tenant, in-memory, all transparent to your applications. You don't have to rewrite a line of code to take advantage of them. And that's why Oracle is such a sticky technology. It's like we keep enhancing it, and we make sure everything keeps working. And you know, I like to say we have the best database, but it's even better when independent third-party industry analysts like Gartner and Forrester say we have the best database. And so over the last 6 months, there have been a number of reports coming out of these organizations all saying that no matter what you're doing, whether it's a data warehouse, it's an OLTP system, it's an in-memory database system, even Internet of Things style system, Oracle database is the best technology out there. And that's been true for the last 30 years. And will be true for the next 30 years as well, hopefully. Okay. The big news today is that Oracle Database 12c Release 2 is now available everywhere. You know, we first shipped during Open World in our public cloud. Then in February, we rolled out 12CR2 in Exadata, and now we have gone production with 12CR2 on-prem on Linux and Solaris. And Windows is probably going to come out next week, and the other Unix platforms probably sometime in April. So great news. All of you have been waiting for 12CR2 to go production on-prem. It's there now. It's there in the cloud. And it's also there at cloud at customer as well. OK. So I talked to you earlier about how the reason we've been successful for 30 years is that we are continuously investing in innovating in the database space and making sure we have the best place for you to store your information. And information is the most valuable part of your almost every business nowadays. And it just gets more important every day moving forward. So you want to have the best database to store and analyze that information. So what I'm going to talk about today are the 3 key areas of innovation that we're working on now in the database group. And I'll talk about what we're doing in 12c. And I'll talk a little bit about what we're going to do beyond 12c as well. OK. So the first thing we'll talk about is in-memory database. And this is a really interesting space because databases were originally designed, relational databases go back to the 70s and 80s, and they were designed very heavily around optimizing or minimizing accesses to storage, to hard disks. And we created things like buffer caches to keep the data in memory that was hot. And that whole architecture has lasted a long time, and it still works well today. But as we move to full in-memory database technology and future technologies like non-volatile RAM, which are likely coming out from Intel next year and other vendors as well, the basic architecture of a database is going to change quite a bit. And in 12c, we've made some initial steps in that direction. And we'll be making some more steps moving forward. And so 12c introduced this concept of an in-memory column store. And Oracle has a very unique approach to in-memory column stores. We provide both row storage, which is optimized format for transaction processing, and the column stores, which are optimized for analytics, doing very high-performance scanning of data. And we do it in a way that both representations can be available. So you can have applications which do both high-performance transactions and real-time analytics against your transactional data, all in the same tables of a database. Nobody else can do that. Our competitors are making you make a choice. This table is really for transaction processing, and I can make that go fast. Or this table is really for analytics, and you can store your data in a column store. But you can't do both. Oracle is very unique in that we can do both. And as I mentioned earlier, this technology is completely transparent to your applications. So all those applications you wrote over the years that do this combination of transactions and analytics, or are purely analytics, can benefit from this technology without rewriting a line of code in that application. OK, so what's new in 12c R2? So there are a lot of optimizations around how you run SQL queries really fast on in-memory column stores that we are steadily working our way through. 12c R1 had our first installment of that. 12c R2 adds a whole bunch of new things, as I mentioned here. Faster joins of big tables, much faster. Complex queries, much faster. JSON, which was new, introduced support for SQL in 12c R1. That's a lot faster as well. We now are optimizing JSON documents in memory. Okay. So when I talk to customers about the in-memory column store technology, the #1 request was the following. I have a big transaction processing system, and I want to do analytics against that data, but I don't want my analytics customers or users to be on the same database instance as my transaction systems, because I don't want somebody running a big parallel query screwing up the performance of my transaction processing. So what we have done in 12c R2 using Active Data Guard is we are now letting customers create a primary production database with no in-memory column store if they want, and just make those transactions run really fast. And then with Active Data Guard, you can now create a copy of your production database that's real-time copy, and you can take all your analytics users and move them over to the standby, and have a column store on the standby that optimizes the analytics there, but provides no overhead to the transaction processing. So this is something our customers are really excited about. It's available in 12c R2 on Exadata and on our cloud. Now, I talked about I'm going to talk a little bit about what's going on in the future. So early next year, we expect Intel is going to ship their non-volatile memory, which is called NVRAM technology. They call it 3D Crosspoint. and other memory vendors we know are working on similar technologies. And once this technology ships, the whole world of database and storage is going to be completely disrupted. So if I have a transaction processing system, for example, that fits in memory, I can store it persistently in the memory, the non-volatile memory. And once I do that, there's no hard disk anymore. There's no flash storage. There's no hard disk storage. The memory is the storage. And the whole architecture of a database from the 1980s that says, well, we move data from storage into a buffer cache in memory doesn't make sense anymore. So we are starting in 12CR2 to evolve the architecture of the database to take advantage of NVRAM. And in the release following 12CR2, we're going to have a major re-architecture of the product. In 12CR2, we will do more of an evolution of the product. And already in 12CR2, we have embedded in the product some ability to take advantage of NVRAM, and we'll be talking more about that as we move forward until next year. But safe to say, the code's already written, it's already in the product, and it's just waiting for NVRAM to start shipping. Okay, so in-memory database is a huge area of innovation. We already do a lot in 12CR1 and R2, and we're going to be continuing to do a lot of investment in innovating in the in-memory space for the next 10 years probably. Okay, the second big area I wanted to talk about is big data. And first of all, what is big data? Everybody's very confused. Well, it's very simple. It's an evolution of building a system for doing analytics using a database, right? And the traditional way of creating systems for doing analytics are called data warehouses. And big data is really, a big data system or a big data management system is an evolution of this data warehouse technology. So what's the difference? Well, in a data warehouse, the relational database is the key engine. It does massively parallel SQL processing. It holds all the data for your data warehouse. As we move to the era of big data, the architecture is evolving. There's still the massively parallel relational database right in the middle of the big data system. But now there's things like Hadoop HDFS that's used for holding lots of data. It's called the data lake. And you might have a NoSQL database engine as well. They're good for holding what's called fast data. They're very good at ingesting lots of information really fast. The next big difference is where does the data come from your data warehouse? So traditional data warehouses capture all the transactional data in your enterprise. Your ERP systems, your billing systems, your CRM systems, they're all sending data as transactions are processed into the data warehouse. As we move into the era of big data, there's new data sources. People are gathering data from the internet. They're gathering data for Internet of Things, devices. All that data is now streaming into your data warehouse, right? And then finally, there's some new forms of analysis developing. Traditional data warehouses might have SQL analytics, roll-up kind of processing, and data mining algorithms. The big data systems are now evolving to add things like machine learning algorithms and graph analytics algorithms to the big data systems. Okay, so what does this all look like? Well, to make it simple, we're going to draw a picture. You started out with a data warehouse, capturing all the transactional data with SQL Access. Now you're adding all the new data sources. The data is generally now being pumped into a data lake running on a Hadoop HDFS. And the interesting data there is being pumped into the data warehouse. And you may have a NoSQL system as well, often capturing things like IoT data. But again, all the interesting data is going to end up in that massively parallel relational database to run your SQL really fast. Now, there's new kinds of analytics, as I mentioned. In that box, we've got SQL, we've got Spark APIs, graph analytics, spatial analytics, machine learning, and data mining algorithms. We have all the different kinds of data, with JSON being the newest kid on the block. 12c of Oracle Database just started supporting native JSON SQL access in the database. on top of things like XML and spatial data, et cetera. And of course, we have all the different kinds of data sources and all the different kinds of developer APIs. And developers, by the way, are becoming a really important focus again for the database team. You know, when we started relational databases 30 years ago, the big focus was on developer productivity. You know, relational databases replaced the earlier generation databases, which did not have very good ways of getting information out. But then SQL came along, and SQL, you know, a few lines of SQL replaced, you know, 10 pages of complex code for doing the same thing against earlier generation relational databases. And then after, you know, the developer focus sort of moved to more an operational focus. And so I'm sure many of you are DBAs, and we spend a lot of time, you know, improving the operational characteristics of databases. But now, as we move to this era of cloud, if you think about it, you know, Oracle, the end game, the cloud provider, is starting to become more of the DBA and doing, you know, we manage all the infrastructure in the cloud, and we are going to, in the future, manage more of the database work. And so developers are going to become more of the driving force around databases as we move to the cloud. And so we're making a huge effort to make sure we have the best developer APIs and drivers for the database. We mentioned a few things here. We have very strong REST capability into the database now with our REST data services. We have Java, of course. Node.js is JavaScript. Python has become a very popular scripting language. We have R support in the database, SQL, et cetera. And a big part of what we're doing with this big data platform is making it possible for SQL queries to run in massively parallel fashion across all your data across the platform. You know, it doesn't matter if the data is in Hadoop HDFS or in the Oracle relational database or in a NoSQL database. You can now run Oracle SQL at high performance across all your data and do joins of all your data across all those different data sources. The technology for doing this, by the way, is borrowed from Exadata. You know, Exadata has something called Smart Scan, and we are effectively doing Exadata Smart Scan-like technology to make this all work in very high-performance way by pushing down the scanning of data in all these different repositories, just like we do in Exadata. We push it down into the storage. Here we push the scans down into Hadoop HDFS and NoSQL, as well as, you know, the Oracle database. And of course, I mentioned earlier, JSON data is now supported natively in database 12c. And under Big Data SQL, of course, all the JSON capabilities in Oracle SQL are now available for your JSON data, whether it's stored in the Oracle database, Hadoop HDFS, or a NoSQL database. And this whole big data platform is available in our cloud. We've been in production over a year now with our Big Data Cloud service, where we support scalable clusters of Hadoop, HDFS, and Spark technologies. And we support a whole host of analytics capabilities across the database and Hadoop, things like Big Data SQL, R, our graph analytics. And coming soon, we're going to have Big Data SQL available in our cloud. In another month or two, that should be up and running. And you will be able to then integrate data across, you know, the Exadata Cloud service, storing database data, and our Big Data Cloud service, and run Big Data SQL queries at very high performance there. And then as soon as we get NoSQL up in the cloud, we'll be adding that to this as well. OK, so that's what we're doing in the big data space. And let's move on to cloud. So cloud, of course, is Oracle's, as a corporation, our big strategic initiative. And from the database standpoint, one of the big things we are doing that is very unique compared to the other cloud vendors is we have been investing now for about 10 years in building optimized servers and storage systems called engineered systems for running our database at really high performance and high reliability, high security. Our flagship engineered system, of course, is Exadata, and I'm sure all of you are aware of Exadata. And Exadata, just like any Oracle database, is optimized for running any workload, whether it's a data warehouse doing parallel queries, or a transaction processing workload, or anything in between, to run all those kinds of workloads at very high performance. We also have a big data appliance engineered system for running Hadoop and Spark at high performance. Our newest engineered system is the recovery appliance that has really interesting capabilities for doing backup and recovery of clouds of Oracle databases. All the Oracle databases in your data center can be backed up by one of these appliances, which the recovery appliance, by the way, is based on the Exadata technology. So it builds on a very mature hardware platform. So these systems have been very successful. We have some of our biggest customers with their biggest, baddest databases running on Exadata. And this is going to be one of the key things as we move to the cloud and we talk about database optimized clouds. Exadata is going to be there. Okay? So what are the three main areas of focus around clouds? Number one, why do people want to go to clouds? Number one, they want lower cost. They want lower hardware costs. In fact, they don't want hardware costs at all. Capital costs go to zero. And then they want low operational costs. And that's lower because now they're outsourcing effectively a lot of the operations to the cloud provider. And the cloud providers have different business models that are basically pay by use. Another big advantage of clouds is provisioning, agility. So on a cloud, if you're doing a new project, you just go to the website and you say, provision me a new database. And in a matter of minutes, you got your database. It could be on Oracle's cloud. It could be running on an Exadata in a few minutes. On-prem, that process could take years to do the same thing. You come up with your design. You put out the bids to all the SIs, or in hardware vendors. Very, very much different experience. Clouds are really fast at bringing projects up and live. The business really loves the agility of clouds. And then, of course, scaling. Clouds can be easily grown. You need some more servers, some more databases. You just ask for them, and they're there, right? Plus, you can scale up, scale across, et cetera. OK, so let's look at each of these three areas and talk about what we're doing for the Oracle database in our cloud. Okay? And I'll try to emphasize, as we go along, some of the things we're doing that's very unique to Oracle's cloud. So around lowering costs, a lot of this is pretty standard. You pay as you go. You pay by use on the cloud. It's all self-service. The end users can just say, provision me something. I don't have to go through some committee in my IT organization to get something provisioned. And low operational costs, right? So again, back to the innovation theme, what is one of the big things we did in Database 12c? We added this new architecture called the multi-tenant architecture. And the reason we added this was to make it possible to run large numbers of database in either a private cloud or a public cloud at very low operational cost, very low capital cost. Okay? And the basic idea was, up till now, the traditional cloud vendors run databases in VMs. So if I want a new database on Amazon's cloud, they provision me a VM, and they run a database in that VM for me. And if you think about it, that's really expensive because if I have now the same number of databases as before to operate, right? Each one has dedicated hardware for it. There's no sharing really at all. With Oracle, we have a much better approach for database in the cloud. It's called multi-tenant architecture. And with multi-tenant architecture, we create a container database in 12c. And in that container, there can be, now in 12CR2, up to 4,096 of these virtual databases that we call pluggable databases. Each one of these virtual databases looks and feels to an application just like an Oracle database. So again, all those applications that customers have written over the last 30 years that were designed for non-multi-tenant Oracle databases now can run against databases in pluggable databases without change. And we can do it at much, much lower cost because we have this capability to manage many as one. And what that means is in this container, let's say you have a few hundred pluggable databases there and you want to back them up. You just press a button and you back up the whole container all in one shot. So all 200 databases just backed up with one operation. You can restore 200 all the databases in the container with one operation. You can do one patch operation to patch all the databases at once. So this makes your operators really scalable. And so on our public cloud, for 12CR2, we now support up to 4,096 of these databases in container, which is very important so that we can run Oracle Database Cloud Service at very low cost. And finally, there's agility. Multi-tenant architecture gives you great agility because each one of these pluggable databases is a unit that can be moved around from one container to the next. And so just like with VMs, you have vMotion, with multi-tenant, you have the same sort of agility with a pluggable database. You can move it from one container to the other. You can move it from on-prem container to a cloud container and back again, right? Okay. So with 12CR1, we delivered the basic multi-tenant capability. It's being used very successfully on-prem as part of private clouds. And it's being used by SaaS vendors, and especially Oracle, on our public cloud for delivering SaaS service. What's new in 12.2 is number one, we've enhanced resource management. We now have memory resource management in addition to the CPU and I/O resource management we had in 12CR1. We now have made things configurable around how heavily you lock down these pluggable databases. So in a public cloud, you can imagine the same container database might have a database that's being used for, NEC, and another customer from Fujitsu could have a different pluggable database in the same container. So you need to make sure that those two pluggable databases do not leak information to each other. They have to be very secure, strongly isolated. But on-prem, where all the people, all the pluggable databases might be sharing, running for the same department and organization, you might want to share information across them. So you can configure how isolated your pluggable databases need to be. And then the last feature I want to talk about is something called application containers. In 12CR2, this lets a SaaS provider who's delivering SaaS applications. And so how do they do that? Well, let's say you're delivering a Salesforce application. Well, every pluggable database in the container is running the same Salesforce application. So you have the opportunity, even in a public cloud, to share the metadata for that application. You can share the reference data that might be things like, show me the interest rates for the last 10 years. All that sharing can be done now using application containers in 12CR2. So we have an even more efficient way of running SaaS applications using multi-tenant in 12CR2. Okay, what about agility? We said, we talked about lower costs. The other reason customers want clouds are around agility, ease of movement, ease of provisioning. Multi-tenancy supports pretty much everything customers want in this space. To provision a new pluggable database, it's simply a metadata operation. You can do it in a couple seconds. Perfect for private and public clouds. If you want to upgrade it, you just upgrade the container once. And all the pluggable databases are upgraded all at the same time. You can move things around with cloning and relocation. And we'll talk about that in the next slide. So in 12CR1, pluggable databases were already a unit of motion. You could move from one container to another, but it wasn't an online operation. You had to basically take the pluggable database down and the application down while you were doing the movement. It might have only been a few minutes, but you still had to take it down. In 12CR2, that's all online. You can now online move a pluggable database from one location to another. That's what we call PDB, relocate. You can clone a pluggable database online. So you can move from a master production database, pluggable database, to a pluggable database in a test or dev environment, all online. And you can do refresh. So what does refresh mean? So if you're in a test environment and you create a copy of a pluggable database in production, every week or so you want to refresh that pluggable database in test with the latest copy of production. And so using our archive log capability that we use for DataGuard, the same capability can be used to refresh a pluggable database to the latest value of production data. And again, we can do this all online. So 12CR2 makes pluggable databases even more agile by making all the operations to move them around all online. Okay, so the third big area for cloud, after lowering cost and agility, is around scalability. So Oracle has for many years supported, SMP scale up, cluster scale out using rack. All that, of course, moves over as we move to private and public clouds as well. Our cloud provides, capacity on demand and massive scalability, et cetera. So what are we doing in this space to make it even better? So rack has been around since about 9i database, early 2000s. When it came out, it was a really revolutionary technology because it was the first database scale-out cluster technology that lets you scale out off-the-shelf package transaction processing systems. Plus, you could also scale out, and run parallel queries for a data warehouse, all in the same architecture. And today, it's still very unique. Microsoft has nothing like this. IBM has something that's sort of, they claim does this, but I haven't heard of any customers who successfully deploy it, except in the mainframe. Amazon has nothing. So this is a very unique technology, and for 12CR2, the big work we did is in two spaces. Number one, if you now run a multi-tenant database on a rack cluster, and the tenants are really small, which is very common if you look at what people do with SaaS applications. For example, a Salesforce application might be running a database for 20 salesmen. And each one of these Salesforce databases, or pluggable databases in this case, don't need a lot of capacity. They don't need the full power of all the CPUs across a rack cluster. They'll probably just run on a single node. And so now rack's cache fusion algorithms can understand that, and they can optimize the pluggable database use of rack so that the rack technology used for synchronizing buffer caches across nodes gets turned off because you don't need to run across nodes for these small pluggable databases. Okay, so that's what we did in 12CR2 with rack and multi-tenant. And then rack was also better optimized in 12CR2 for running big parallel query workloads on a cluster. Before 12CR2, we were limited to 64 nodes in those kind of workloads, and now we can go up to hundreds of nodes for parallel query. Okay. Another big thing we're doing on the cloud is around bursting. One of the reasons customers really like clouds is they buy capacity on demand as they need it. And most businesses have this very cyclical pattern where during the course of a quarter, a business quarter, they need, in this example, let's say 16 CPUs to run their transaction workloads. But then at the end of the quarter, after it closes, they're running all kinds of very large batch jobs to analyze the quarter results. And they need a whole bunch of more processors. And in this case, we're saying they need to double the number of processors. And so in a cloud environment, the thing customers like is they only have to pay for the 16 CPUs that they need for the course, most of the quarter. And then at the end of the quarter, they double the capacity. They pay for the extra capacity to close the books and run the big quarterly batch processing runs. And then when that's all over, they go back down to 16 processors. So we call this bursting in our database cloud services, and we support this on our cloud. With 12C, actually 12C and 11G. Okay, so we have one major new feature we've added in 12CR2 beyond multi-tenant and in-memory, and that's something we call sharding. And sharding has been something customers have been doing for many years. And the customers who do this are basically customers who are usually running really large transaction processing workloads, usually huge ones. So the first customer I was aware of that was doing sharding was Amazon.com. And what they wanted to do was they didn't want to have just one e-commerce database for doing their transaction processing for the world. They wanted to split the world up into geographies and have a separate database for each geography. And they wanted to do this for both scalability reasons and for availability reasons. You can't have a single database going down and the whole world of your Amazon's business goes down, right? And so what they did is they created what we now call shards, but they did it by hand. Okay, and they created these sharded databases that were real Oracle databases in all the different interesting regions of the world for their business. And then they wrote their application code such that all the different users of their e-commerce site were sort of tagged with a region. And when they sent in their transactions to buy products from Amazon, they would be sent to the appropriate shard or sharded database shard for that region to process the e-commerce transactions. Okay, so the idea of sharding is pretty simple. And what we did in 12CR2 is we basically said, okay, so customers who want to do these big sharded transaction processing systems have to do it all by hand today. It's actually a pretty tedious process for them. So we have completely automated that process. In 12CR2, you can basically just tell us which are the shards you want, what are the geographies, et cetera. You create something called a shard key. So in Amazon's case, the shard key is the location or the region, right? In other cases, it might be something else. For example, I was just talking to, in Japan, Docomo has a big Oracle database and that does their billing systems, and that database is actually sharded. And the way they shard is actually based on your phone number. They take some of the people, they divide all of Japan into like 5 regions, and people in each region, which is defined by their phone number code, go to a different shard of the database. But anyway, with 12CR2 now, this is all automated. You can create a shard key from your application. You have to tell us which shard key your client application is part of. So this is not a transparent technology. You do have to go in and write your application to provide us with this shard key. So it's not quite as transparent as most of the stuff we do over the years. RAC is completely transparent, no rewriting of the application. Use sharding, you do have to rewrite the application a little bit or design it from scratch to have these shard keys. We also provide SQL across the shards. So one of the things Amazon can't do is they can't run a SQL query across all these sharded databases that they use for e-commerce processing. With 12CR2 sharding, we actually support that. You can run effectively a distributed query across all the shards and get the sum of all the sales across all the regions, if you're an e-commerce provider. Okay, so Sugihara-san talked a little bit about Cloud Machine. So this, again, is one of these really unique things Oracle is doing in cloud that nobody else is doing. If you use Amazon's cloud, Amazon is a complete lock-in, right? Whatever application you write to their cloud, whatever database you use there, it only will run on Amazon's cloud. You have to bend over backwards, to write an application that isn't locked into their cloud. Oracle is very different. Our database software, all of our software, can run anywhere. You can run it on Amazon's cloud. You can run it on Oracle's cloud. You can run it on Microsoft's cloud. You can run it on-prem. And now you can run it also for what we call Cloud@Customer or Cloud Machine. And this is very unique. Microsoft doesn't do this either. But basically all the hardware infrastructure as a service capabilities we have in our public cloud, you can now put in your data center. The PaaS services we have in our public cloud, you can put in your data center as well. And we will also run the infrastructure for you, the people for running the infrastructure, for running the database PaaS services, we will provide as well. And we will provide the same business model that you use on a cloud. You pay by use or by subscription. So this is a really interesting transitional technology, because today, if you want to move an application that's a database application from on-prem to the cloud, you have to lift and shift everything that you have on-prem into the cloud. With Oracle Cloud at Customer, you don't. You can just say, OK, I'm going to leave all my applications running on the same infrastructure as today. You know, the same Linux servers, the Java servers, whatever it is I use to run my application. But for my databases, I'm going to move all my databases off this random collection of server and storage hardware I've created over the years and move to a cloud infrastructure. There's a private cloud on my premises using Oracle's public cloud software technologies. And so this is really attractive to customers who want the benefits of private cloud, but aren't ready to just move everything lock, stock, and barrel up to a cloud provider. So we're seeing a lot of interest in this. We just started shipping the Exadata Cloud Machine in December, and we are seeing a huge interest in the cloud machine from our customers. OK, so just to summarize where we are in the cloud from the database standpoint, we have 3 cloud services today. We have a low-end service called Exadata Express Service, great for doing dev tests, great for running small production departmental applications. It's all using Oracle's 12c multi-tenant architecture. It runs on our Exadata optimized infrastructure for cloud, and it's as cheap as any. You can provision a database at extremely low cost because of our multi-tenancy. We are every bit as cheap as running a database on Amazon. Then we have our enterprise database cloud service, which scales up a bit more. You can have bigger databases, more cores of processing power. You can run your mission-critical apps there. You can use things like rack technology. And then we also have our Exadata infrastructure, where you can do everything I mentioned before. You can do dev tests, run production departmental applications. But you can also now run the biggest, most highly available, most scalable, most demanding enterprise applications in our public cloud using the Exadata infrastructure as well. OK, so with that, I'll conclude. And I just want to summarize some of the things we talked about here. As we've done over the last 30+ years, we are making major investments in our database technology to make sure that we continue to have the leading database technology out there in the market. Even as we move to cloud, you always want to use the best database technologies out there. So with Oracle's cloud or Oracle on-prem, you can get to use the best database technology. And I showed you the proof points from Forrester and Gartner that validates the claim that we have the best database technology. Amazon, what database technology do they have? They have Postgres. They have MySQL. These technology, if you look at these analyst reports, you'll see that those technologies are way down, very weak in comparison to Oracle's database. Okay. So the 3 big areas of investment in 12c and also moving forward to beyond 12c are in-memory database. And I mentioned there, the in-memory column store technology we have is very unique, highly differentiated. And again, the analysts, the Forrester report on in-memory database, the Gartner report on in-memory technology, which they call HTAP, high performance transactional and analytic processing. We are number 1 in that space. And then moving forward, we have already designed into 12CR2 support for NVRAM technology. This is non-volatile memory. Intel is shipping it next year. Other vendors will be shipping it as well very soon. And this is very disruptive technology. All those storage servers you have running databases today are going to become obsolete very rapidly. Okay. Data warehousing technology is now evolving to big data. We have a whole big data management platform available where customers can use our Exadata massively parallel database for running high performance queries. They can use Hadoop to form data lakes. and they can use NoSQL databases as very high-performance ingestion engines for IoT. And one thing I didn't mention, actually, that I should mention is our Database Enterprise Edition license now includes the ability to use our NoSQL database as well. So I know a lot of customers were interested in NoSQL database, but they had to go off and buy a separate license for it. Now, if you have some spare licenses for Oracle database, you can actually use them to run our NoSQL database as well. That's something we just started doing a couple months ago. And then finally, on-prem to database optimized cloud, I talked about what's really different about what we're doing versus what Amazon and other cloud providers are doing there. Number one, we have the best database. We already talked about that. Number two, we have the best infrastructure for running a database. We have a database optimized infrastructure that's built using our engineered systems technologies like Exadata. Soon we'll have the recovery appliance up on our cloud as well. And this gives us a highly differentiated cloud offering for running database applications versus Amazon and others. We also have this capability called Cloud at Customer or Cloud Machine that lets you get all the benefits of a public cloud, but you get them while running it in your own data center or your SI data center. And it's a very nice transition where you don't have to move everything, all the applications and all the databases to get the benefit of a public cloud. You can just leave all your applications where they are and bring in a bunch of Exadata cloud machines and get all the benefits of the cloud subscription model, the low operational costs, no hardware costs, et cetera. And with that, I'll close, and thank you for coming.